Have you ever just looked up, seen a bird gliding across the sky and thought, how on earth are they doing that? I mean, there's no engine, no propellers, just wings. It really does look like magic. But it's not. It's actually a masterclass in physics. So let's break down the incredible science that lets birds completely own the sky.
And that really is the big question, isn't it? We humans need these massive jet engines, thousands of pounds of fuel, just to get a plane off the ground. Birds, on the other hand, they do it with nothing but feathers and bone. It seems like it should be impossible. So where does that power to just defy gravity actually come from?
Well, the whole secret, the entire trick, is right there in the wings. But here's the really brilliant part. A bird's wing isn't just some simple flap. No way. It's this incredibly sophisticated two-in-one tool that evolution has perfected. It does two critical jobs at the exact same time. It creates an upward force we call lift and a forward force we call thrust.
To really get this, we've got to look at a bird as this perfect, self-contained flying machine. It's an engineless wonder that has totally mastered the air it moves through.
Okay, so it all boils down to two fundamental forces. If you can wrap your head around these two ideas, lift and thrust, you've pretty much cracked the code of flight itself.
So first up, we have lift. You can think of this as the anti-gravity force. It's the upward push that's constantly fighting against the bird's own weight, pulling it down. For a bird to stay in the air, the lift its wings are making has to be at least as strong as the pull of gravity. It's a constant battle, and lift is the hero.
But, just floating in one spot isn't very useful. To actually get somewhere, a bird needs thrust. This is the force that pushes it forward, letting it cut through the air and overcome the drag that's always trying to slow it down.
So let's just make this super clear. Lift is the up force. Its whole job is to keep the bird from falling out of the sky. Thrust is the forward force, and its job is to move the bird from point A to point B. And the absolute genius of a bird is that it gets both of these, up and forward, from one amazing tool, its wing.
So you might be wondering, how does a simple wing create that powerful upward force? Well, the real secret isn't just in the flapping motion. It's in the wing's very specific, very clever, curved shape.
Okay, this is so cool. Picture a wing moving through the air. The air hits the front and splits. Some goes over the top, some goes under the bottom. Now, because the top of the wing is curved, the air going over the top has a longer path, so it has to speed up to meet the air from the bottom at the back. And here's the kicker, thanks to a rule in physics called Bernoulli's principle, that faster-moving air creates an area of lower pressure. So now you've got higher pressure under the wing pushing up and lower pressure on top pushing down. The higher pressure wins, and boom, that's lift.
All right, so that special curved shape explains the up force, the lift. But what about the forward force, the thrust? For that, we need to look at the powerful motion of the flap itself. When you see a bird flap its wings, the real action, the main event, is that powerful downstroke. And it's not just pushing air straight down. The wing is angled just right, so it's pushing air down and backward. This is the power move, the one that actually propels the bird forward through the sky.
And this is where a little high school physics comes right into play. It's a perfect example of Newton's third law. For every action, there's an equal and opposite reaction. The action is the wing pushing the air down and back. The reaction, the air pushes the bird up and forward. It's that simple and that elegant.
Of course, what goes down must come up, right? But the upstroke is all about being smart and efficient. The bird actually folds its wings in just a little bit, making them smaller to reduce the resistance from the air. This makes sure it doesn't lose all the forward momentum it just created with that powerful downstroke. Think of it as a quick reset, getting ready for the next big push.
So when you put it all together, the lift you get from the wing's shape and the thrust you get from the flap, you realize something pretty incredible. The bird isn't just moving through the air, it's actually using the air. The air itself becomes the engine.
Honestly, there's a really easy way for you to feel this for yourself. The next time you're riding in a car, as a passenger, stick your hand out the window, hold it flat, then just tilt the front of your hand up a little. You'll feel the air instantly push your hand up. That's lift. You're creating it yourself, using the exact same principle of air pressure that a bird's wing uses, just way, way more perfectly.
So, if you're gonna remember just one thing from all of this, let it be this. This one sentence really sums up the whole shebang. Birds fly by flapping their wings to push air down, which in turn creates both the upward lift and the forward motion they need. It's simple, but it is profoundly effective.
So in the end, why don't birds need engines? Because their wings have evolved over millions of years to turn the air itself into an engine. They slice it, they compress it, they manipulate its flow and pressure to pull off the daily miracle of flight. So the next time you see a bird just cruising overhead, you'll know. You're not just watching an animal, you're watching a master physicist at work.